So I'm Bart Massey. I'm a professor at Portland State. I've been geeking around the computer world for 30 or 35 years. I don't know if Marcus has seniority or not. Probably it's between the two of us. And one of the things I got hooked up with pretty much as soon as I got hooked up with UNIX systems in the early 80s was a little language called M4, a macro preprocessor that was full of cool things. By the way, so since I'm old school today, I decided I'd go that, oh wait, it's not showing up properly. Oh crap. My font failed. Oh, sorry. This was supposed to be OCRA and I was doing it anyways, but I guess we'll have to stick with something readable. My apologies. I don't know what happened there. I can fix it, but I don't think I'll take the time. What did the PDF? So anyway, M4 is one of these systems that I've found incredibly useful over the years. This is maybe esoteric for some Zissou compliant version of esoteric, but yeah, there we go. And I was going to ask now. I've spoiled the quiz, which was for Font Geeks, which was what font is this? This is OCRA. This is one of the old.
Sure, it's not Comic Sans.
I am quite sure. I was very careful about that. Thank you very much. I'm not quite sure how to get events to go full page for real though. A presentation.
See if you're on Linux.
There you go. So
He was tackling me earlier.
I apparently just forgot to install that font on this machine. Oh well. So the point is, old school. This is something I've been using forever. I found it incredibly useful. And the way I use it is a development tool for domain-specific languages. That's what a DSL is for the people who missed it. It's a way to say, you know what, I have a particular set of problems. I need a language that's customized to my particular set of problems. But you know what, I don't really want to write a compiler or an interpreter with a full-scale world at it because that takes months and I'd rather be solving problems. For rapid prototyping of DSLs, I think M4 is epic. DSLs are traditionally DSL implementations are traditionally interpreters. There's no reason it needs to be that way. M4 is going to do this in a little different way. So yeah, I've been using it since the early mid-1980s. I was sort of looking back over the major projects I'd done with M4. This is the 6 of them. Starting, going back in the early 80s, when I was working at Tektronix, and I built a little pseudo-assembler for the Motorola 56K, the processor from hell, that sort of compiled down into 56K assembly for doing audio operations. It was as DSL as DSL could get. I wrote macros. I'll talk about them later, to do exams, to format exams when I was teaching at Portland State. I, like everybody else, had to do something about good old bind and its table nightmares. My solution was an M4-based thing. For my master's thesis, I wrote a compiler backend for a compiler for FGHC, a language which I hope to talk about in the future Zissou thing, that actually took pseudocode, took bytecode to native code for a couple of different backend targets. So it was nice that it was easily retargetable. Used it as a planning problem description language for my doctoral dissertation. And then soon after coming to Portland State, I wrote a system, I wrote the first version of a system called XCB, which is a X-Lib replacement in the X-Window system. Jamie Sharp, under my supervision, wrote the first version of that all in XML. M4. The second version was in XML. We don't talk about the second version. But the first version was in M4, and we used it to generate about 3/4 of the C code in XCB. So I think it's epic. And for the 2-3 years in a row out at Open Source Bridge, I'm like, I want to give a talk about M4. I want to give a talk about M4. And I always got the same, no, it's M4. Oh my gosh, it's the scariest thing in the world. I finally gave up. I get why you might think that. But my primary message, the thing I want you to walk out of with at the end of my time today is, that's wrong. M4, there's nothing particularly scary about M4. It's a really, really useful tool that works in some places where other things are really awkward to fit. And all you have to do is just treat it right and pay some vague attention, and you'll be very, very happy with it. But the problem, of course, is bad M4. By bad M4, I mean sendmail config files and auto tools. Oh wait, that's what everybody's seen of M4, and so somehow they got the idea that M4 is horrible. Look, it doesn't have to be like that. And one of the things I want to talk about in this talk is sort of how you make it not be like that, how you write M4 that actually people can use. I mean, I feel a little out of the spirit of Zissou here because, you know, I'm here advocating that you actually use this language, not just exploring how wacky and weird it is, but, you know, it's how I feel, so there you are. If you do it right, it's really not hard, it's really not scary, it doesn't have to become like AutoTools or assembly. So what do I want to talk about? I want to talk about what a macro preprocessor is and how this particular macro preprocessor works. I want to give a little example, which I'm realizing as I stand here in front of you that I forgot to bring with me, so I'll probably have to fiddle with the network for a minute, of how that looks. I want to give you some style tips for how you can write M4 without getting yourself in epic trouble, and I do want to talk about some of the pitfalls that may make M4 not the perfect language for everything. You know, like I say, I use it in a really narrow way. I need a little meta language. I need a little domain-specific language for doing some stuff with. And so I pull out M4, I write that domain-specific language, and I go on. You know, I certainly don't claim that it's a Swiss Army knife. It's a tool that you can use in some narrow ways to do some cool stuff. By the way, obviously, for those of you who know me, do not hesitate to chime in with questions, comments, heckling, whatever it is you need to do. I'm happy with that. Don't hold things till the end of the talk. That would be silly. So what's a macro preprocessor? Well, the idea is that, you know, well, you know, because you've all seen CPP, right? Which is, you know, sort of the vanilla macro preprocessor of choice for C-like languages, specifically C and C++, but even Haskell uses it. Oh my gosh. What? It does.
It absolutely does.
I've absolutely done so.
Well, you did it wrong.
I'm doing it wrong, arguably. There I am. You know, the idea is that I somehow embed right in the source text itself some macros, some definitions of when you see this text, expand it to this other text. And the system then is sitting there dynamically reading in the text, and when it comes to a definition, it remembers it and goes on, and when it comes to a use of that definition, it replaces the, you know, use text with the expansion that it's supposed to replace. And that's the whole story. You know, the primary ones, like I say, that you're familiar with probably are CPP and also LaTeX, if you've ever used that, is sort of an epically scary macro system. See, I don't get people who are scared by M4 but not scared by LaTeX. That to me is just like, what the? Having written a lot of both.
What about Common Lisp?
Yeah, Common Lisp has a lovely macro system, which isn't very scary at all. In fact, the old school Lisps had an even more scarier macro systems, absolutely. We actually did a Lisp implementation, Keith Packard and I did, in the mid-late 80s, where macros were not observationally distinguishable from lambdas, and because we were in a functional subset of Lisp, and there were some cool implementation things you could do there. Macro preprocessing is powerful. The Lisp macro preprocessing is a little different though, because it isn't really, strictly speaking, text to text. It isn't done during a textual translation stage. There's no point at which I can recover the preprocessed Lisp. It's done at the semantic level. And so people throw the word macro around for a lot of different things. I'm going to reserve it here for text-to-text transformation.
Oh, but there are, what do they call it in Lisp? There's a macro, reader macros.
Yeah, absolutely.
Yeah.
So Lisp is, absolutely. But the point is, the places you've seen it are probably those few places. And yeah, no, CPP is not the answer. I just want to get that off my chest right now. First of all, it's not Turing complete. Well, what your macro preprocessor should be Turing complete? Well, I'm about to show you. But, and also, you know, it's really hard to say anything very interesting in it. It doesn't have a lot of the macros you need, even in the non-Turing complete world, to do cool stuff. And the third thing is that it's really aimed at C. It's tokenization rules. You know, it's going to be tokenizing because you kind of have to do that to figure out what the definitions are, what the expansion text is. And its tokenization rules know about C. And so heaven help you if you want to use C in a language where double quote means something else. or where identifiers are allowed to have slashes in them, or whatever, right? We've done. So M4 is designed to be the generic answer. You're not supposed to have to think about what your source and destination language is. There's a few things because it's really hard to get away from them, but for the most part, first of all, it's as agnostic as it knows how to be. And second of all, any of the non-agnostic stuff is customizable so that you can try to get it at least as out of the way as you can for your particular application. So the idea is that rather than CPP, you would probably be better off using it as a ASCII preprocessing language. It would probably work better, except that everybody's terrified of M4 would never be willing to use it. I don't understand. I really don't. That XCB system that I was talking about a while back ended up being rewritten as an XML description with an XSLT transformer. Yes, because people thought that was better than having to learn M4. And when that failed, then they rewrote the XSLT as Python, and now everybody's happy with their XML and Python. I was like, wow, that's 2 more rewrites than I would have done. And it was my code. What's the key? The key is definitions. And so like I said, macro languages are all about definition and expansion. There really isn't anything else interesting to say about them. So, the easiest thing to do here is obviously just to fire up M4 and sort of get an idea of what's going on. The only confusing thing here is, and by the way, is that big enough people can read it? I can make it bigger. That's easy.
A little bit bigger. Yeah.
Yeah, I can go bigger yet if people want. That's there. Now it should be legible to everyone, I hope. If not, you have worse vision than me. I'm sorry. Oh, yeah, and of course now that. All right, so let's
We can't see the last.
let's try one more time. Sorry, I don't want to burn minutes in my talk, but apparently that's where I'm going. Let's grab this and drag it. Oh no, that doesn't do the right thing. I'll make it smaller and then Control Shift. Woohoo! That should be big enough. So let's define X to Y because that's the simplest thing you can say. And now I can do things like this, and it really doesn't care. So you'll notice that I'm inputting a line and then it's outputting a line because UNIX, but never mind that. But the point is that if I say A, B, C, D, E, X, F, G, H, I, so that X looks like an identifier thing, then the X just gets magically replaced by Y. Okay, big deal, right? Congratulations to you. The thing is that the first thing to notice is that define itself is just a built-in macro. There's absolutely nothing magic about it except that it happens to be bound to a built-in definition that does the define thing. And so I can redefine define to do other things. I can do all kinds of crazy stuff if I want to. It's very, very generic. This is going to be a crazily flexible system for doing what it wants to do. I'm going to try doing this way and see if it works out all right. Not so much. Maybe I should Control Shift minus. That's not going to work. Oh yes, I agree. It's supposed to. Oh, I'm on page width. Let's try.
Shift. Just happens.
Let's try 100%. Well, that doesn't look it. Well, I'm not on Mac. I'm on Linux. I'm running Linux here. Yes, there we go. Ha ha ha. So that's pretty much the whole story of definitions. It's not a very complicated or interesting story. Of course, plain definitions would be boring. Even CPP will let you do better than that. And so we're going to allow ourselves to have arguments to our definitions, and that's going to let us do more interesting definitions. The arguments are positional, which is really, really sad, but there we are. I love the way that OCRA renders brackets. The arguments are positional, which is kind of sad, but that's where you are. By the way, everything I'm going to say today is about sort of generic 1980s M4. GNU M4 has a number of extensions. By number, I mean very, very large number. A, I don't know them that well, and B, I generally choose not to use them because they're not necessary, but they're kind of cool. realistically, it's almost the only M4 implementation around anymore, so maybe you should be using that, I don't know. But I'm not, because, you know, Zissou. What this does is define the term bracket to take the thing that you pass to the bracket macro and put $1 around it. Notice that those single quotes, the double quotes, by the way, are not part of the syntax. That's just me double quoting things so you know what's text because OCRA. But notice that the single quotes there actually are, you know, doing something special. And yes, notice that they're supposed to be matched. The Unicode people totally broke the world a while back and decided that for some absurd reason that thing that in ASCII was clearly an apostrophe or single quote wasn't in fact, it was a prime. And so they put the close quote, single quote off somewhere in UTF-8 hell. And so now we're stuck with that forever. But because M4 precedes UTF, you're going to get that bad rendering. But that's supposed to be matched. There aren't that many match pairs in ASCII, so it's terrible to take one away, but they do.
You can change to another one if you like, though.
Yeah, you absolutely can redefine the brackets to be whatever you want. And in fact, you can define them to be the same thing, and the right thing will happen, except that you're going to find out that you need to nest quotes a lot in M4, and so I don't recommend that plan.
Curly brace.
What? Yeah.
Curly brace is my favorite substitution.
Curly brace is absolutely fine. You'll notice that both Auto Tools, I don't remember what Sendmail does, but Auto Tools uses square brace. You know, pick your favorite. By the way, a lot of the reason I think why people are so frightened of M4 who've used Auto Tools is because they haven't figured out yet that those square braces are just quotes. It's not obvious syntactically, and nobody ever bothered to tell me. If I do this, then I get a macro that will do sort of the sensible thing, which is to say, you know, once I've done, let's see if I can do this. No, I can't. How about this? No, can't do that either. Come on, gotta be able to do something.
Doing something for you.
Paste. I want to do paste. There we go. So now I've defined the bracket thing, and so now I should be able to say sort of the Captain Obvious thing, which is bracket x, y, z, z, I don't care, x, y, z, z, y, 1, and it should sort of, yeah, put brackets just like this, right? Nothing, I mean, it doesn't seem that frightening or scary or anything, right? I mean, I should say a little bit maybe about the evaluation rules, which is that when it comes to, bless you, an expansion over there, you know, when it comes to a macro definition followed by a paren, it assumes that it's going to see that, it parses to the right paren, and, you know, arguments are separated by commas, which aren't here right now. But anyway, the point is then it expands this text. A key difference between this and something like CPP is that the expansion is recursive. It will keep expanding something until it's out of things to expand. And that's important. It turns out to be a good thing if you're careful and a bad thing if you're not careful. The point is this. If I redefine bracket, by the way, notice uppercase there, that's what you normally do just because you're not insane. If I redefine it to be this, the interesting question is, will it work? It certainly the definition works. What happens now when I say bracket A? Oh, it works just like it's supposed to, because it turns out that the $sign will be delayed because of the expansion rules. Oh, okay, fine. Don't really care. But if I'm nesting definitions, which is certainly a thing I can do, you know, define X to be, define Y to be $1. Oh, now things get a little bit interesting, right? I'm not sure why I used a lowercase x there, but let us never speak of it again. Now, what happens when I say Y? I get nothing. What if I say Y of A? Oh, I get A. Okay, so that works like I expect. But notice that that definition happened even though I haven't run X yet. That probably isn't what I wanted. What I probably really meant
Actually, X
was...
is going to be an
What?
empty string, right?
And what does X do?
X should just be an empty string there. That's an empty
Yes,
string.
X should be defined to be the empty string. If I say X, I don't get anything. Because the definition got expanded at the time that it was doing the outer define, right? The inner definition got expanded and happened. So if I define Z to be quoted, define Y to $1, then what happens? Am I okay now? Let's see. Is Y, oh sorry, I shouldn't have used Y. Is Y still defined? Is it undef or undefined? I never remember.
Undefined.
Undefined.
I'm pretty sure.
So right now we know that thing's not defined. Let's just do that again.
Yeah.
And you can tell that undefined was correct, right? What would happen if the real keyword had been undef?
It would have printed up.
It would have printed undefined. Why? Because there would have been no macro pre-processing happening. So let's see, what is W now? Oh, W is just W, it hasn't been defined yet. But after I say Z, what happens? Well, now when I say W of 1 of A, I get, oh, W of A. Well, that's confusing. So what happens when I say Z of B? Now W of A is, oh no, it's still not defined. Right? Oh, right. Nope. Interesting.
So maybe B is now defined to
I'm
be?
completely
No, wait.
confused
Oh,
now. I'm
no.
going to start over. My guess is that we screwed up somewhere along the way. The point is that typically you want to nest these quotes. I'm going to do this the way you would normally write it and not think about all the weird special cases that I'm apparently failing here. Now W of A is just W of A. It's not anything yet. Let's say Z.
Z doesn't take an hour.
And it doesn't do anything, so it got expanded. And now, oh right, it's because the Z definition had a $1 in it. And so doing Z with an argument, yeah.
Yeah, is the $1 an argument to Z or to W?
Now W of X or whatever, I don't know, D's fine. Oh gosh, now I'm lost. Oh well. The point is, you got to be really super careful with the quote. And I refuse to go farther than that right this second. It's weird, because I've run all these examples beforehand.
Is it that you define W, and then in your subsequent definition you weren't defining W because you didn't have W quoted?
That's probably exactly right. So one of the habits that you get in is to also quote the names that you use themselves, because they can get expanded as well. And so yeah, there's that kind of problem. But I didn't have this problem earlier when I was working out this demo, which always works except apparently in talks. Anyway, who cares? Let's not think about it right this second. And I still am missing a close quote. By the way, a print matching editor is really helpful in this setting. What is W? Expands to W. What's W? Oh, sorry, W of 5. It's W of 5. We run A. A of 6 expands. So the $1 here is getting matched apparently with A. So now what's W if I run that? It's 6. Okay, that's what I expected. So the point is that you got to be really careful about how much you protect these things, right? That $1 there is actually being matched with the definition of A, not the definition of W. And if I want to do that, if I want to fix that, what do? Oh, I add more quotes to protect it. And so you very rapidly learn that you got to count your quotes really super carefully. I knew I could make this demo work. All right, I'm almost out of time. Let me see what we're going to talk about next. So the point is that you've got positional arguments, you've got substitution. I already talked about the substitution rules and the quoting protection. The cool part about M4 is that it's a train complete language because I'm going to be able to recurse. And to be able to recurse sensibly, I'm probably going to need some kind of recursion control. At least old versions of CPP also let you recurse, but without any good way to stop recursing, it didn't turn out to be a terribly useful way to go. Here we have the if-else macro, which takes a string as, takes the first argument as a string, the second argument of a string, compares them to see if they're the same string. If they are, then it executes the if-age, otherwise it executes the else-age. Okay. Clear enough? So it's a 4-argument if. And then there's the eval macro, which eval basically takes a C-style expression, which may include conditional operators, all that kind of crud, and actually evaluates, takes a string that represents that, parses it, evaluates it, and returns a string representing the C-style answer. Clear enough? So, I mean, if I wanna sort of do Captain Obvious's thing here, it's, oh, sorry. It's, if I eval, sort of 3 plus 2 is greater than 1, I will get 1 because that's the C for true. If I say if else, 3 comma, I don't care really. 3 comma 3 comma yes comma no, I'll get yes, and so forth. Clear enough? Nothing too mystic there, I think. So, okay, great. I can actually do some evaluation.
Did the expressions you're having eval get expanded beforehand?
Well, they get macro expanded because,
yeah,
the arguments to any macro always get macro expanded, so it's not a special case, absolutely. Yes.
So they're strictly expanded?
They're expanded as much as quoting doesn't protect them from. Yes, absolutely. They're protected. They're expanded until the macro preprocessor decides it's done expanding them, which is same rule as any other thing. There's no difference between.
But they're expanded like strictly, not lazily.
Oh yes, strictly.
Yeah.
Absolutely. Yes. They're expand arguments first, then.
Yeah.
Absolutely. Yes.
In all cases.
Yes. Yeah. M4 isn't lazy. Lazy M4 isn't interesting to think about.
Now wait a second, for if then else is the else, I haven't really thought about that. Both branches are expanded.
Right, you better protect those with some quoting, or else they're going to get expanded up front, and the bad thing's going to happen. Absolutely correct.
Everything will be the
Yes, you have found one of the secrets, and if you look at this, very easy to understand definition of factorial. There it is. We say, well, if the argument is 0, and because of that string comparison. But that's okay, because we're going to be careful to only pass strings representing numbers to factorial. If the argument is 0, then we return 1. Otherwise, we evaluate, the argument times the fact function of the eval of $1 minus 1, and then there's some closing to close it all up. And like I say, you really want an editor that does paren matching here, or else your brain explodes. And quote matching. The good news is there are some rules for eating white space in these definitions, because otherwise you would go mad. And in particular, in certain specified places, like after a comma, the white space is eaten to the end of the line. It's also eaten until the beginning of the line. And so effectively it's all eaten up. And so I could actually write this thing a little bit more readably. Not worlds more readably, but a little bit.
So what triggers the delayed evaluation? If you delay evaluation by putting quotes around something, then when are you delaying it to?
When you evaluate it one more time, the next time the evaluator is called independently, each time the evaluator is called, if it finds a quoted thing, it strips the quotes off and leaves them alone. So if it doesn't find quotes around it, then it will start to macro expand it, right? Until it finds a quoted entity, which it will leave alone. So basically, there's a strip quotes and leave alone rule that is on the outside, so that if your thing is quoted, the quotes are thrown away, and that's the whole evaluation. The evaluation of quoted string is the string, without the quotes. So you gotta count the number of times things are gonna happen. You gotta watch out.
Yeah, you sort of have to see all the,
I'm not, I say it's not scary, and it's not scary. You figure it out really fast, but you kind of have to do it. I can run that, we're running out of time. But trust me, I've done it a bunch of times. It puts factorial in it. The last thing you should probably know about is this weird M4 specific concept of diversions. A diversion is something that is sort of an area that the macro expander can write into. The cool thing about diversions is that when I divert into a diversion, the stuff goes out there, and later I can undivert the stuff, and it's all run through the macro preprocessor again, if I so choose. And so I can use it as sort of a scratch space to expand stuff into. So for example, if I want to create an appendix while I'm preprocessing some text document, I can sit there and have a diversion that represents the appendix, and as not appendix, that's not what I meant, table of contents. And then, I can process chapter titles and stuff into the table of contents thing. I can process the rest of the text into a different diversion, and then at the end I can undivert the table of contents diversion, then undivert the other diversion, and my stuff comes out in the right order. Woohoo! But note that when something's undiverted, it's also re-macro preprocessed, so you want to take that into account when you go. The most common use of diversions is that it turns out that divert -1, by the way, divert 0 just puts everything back to standard output, which is what you expect. And divert -1 throws everything away. And so the problem here that you may have noticed when we were typing at this thing is that when I do a line like define x, y, I get a blank line back because the white space eating rules don't eat it, and it's really super annoying. It turns out that I can use comments to play with things. I can define x to y, and then use the delete to new line macro, which actually gets rid of the white space.
Leaves you with a space.
But it leaves me with a space, right? So I have to butt it right up against it. This doesn't seem all that fun. DNL is normally just used for comments. And in that setting, it works just fine. But what you typically do for reals is you divert -1, and then you can put any crap you want in here, and the only thing that it's going to pick up is the definitions, because it will macro expand the stuff, and so any definitions you make will happen. And then later I can divert 0 to get things back to standard output, and then I can say A and B will appear. Yay! And so I can put sort of arbitrary comments and descriptive text and crap, and the only thing that it's really going to do as long as I'm diverted -1 is process my definitions for me, which is often a very useful mode. So typically you'll see macro files sort of start with a divert -1 and sort of end with a divert 0.
So you use other numbers, if you wanted a table of contents, it could be divert 1 or divert 2?
Yeah, absolutely. I think you're typically allowed up to, believe it or not, 9 diversions. Divert 1.
So like 9 numbered variables.
Yeah, 9 numbered, well, sometimes variables, but really more like 9 numbered temp files. I mean, because these things typically contain, they're actually typically implemented as temp files because, old small memory computers. And so, yeah, the main plan for diversions is to keep you from having to screw around with sort of multiply reprocessing the same text. LaTeX, you typically run it 4 times. Oh, the first time builds the aux file, and the second one builds the stuff the bib file needs, and then you run bib, and then you run it again, because now you have this site. With M4, you can use diversions to take care of all this and be able to do single pass processing.
So do diversions actually go to separate files, or can you
You
merge
can't
it?
tell. It's not observational. It's not observationally distinguished.
Yeah.
But in practice, the implementations tend to throw the diversions into temp files, and when you undivert, they tend to pull it back out of the temp file because they're afraid they don't have enough memory for it. So, the technical way you do this is you have a file full of macros, and then you have a file full of stuff that you want processed with those macros. And typically those are in separate files. You don't typically mix macros with your stuff, definitions with your stuff, and because that would drive you insane. You instead put the definitions in a separate file that you would call front. And basically when you invoke M4 on a pair of files, it does exactly what you think. It processes the first one, and it processes the second one, you would have thought. By default, it writes to standard output, as you would expect. And like I said, there you go. You don't have to rescan because diversions. And this is the example that looks now like I'm not going to have time to do. But this was one of the earliest M4 domain-specific languages I did. I wrote a whole bunch of macros because I was working in a mixture of, I was working in TROF originally because it was that long ago. And I would write an exam question, right? Question, blah, blah, blah. And I would write, I would have some instructions and stuff up. All my things look the same, right? The question would have a part, multiple choice things would have choices, and blah, blah, blah. If you're working in TROF, defining all this as TROF macros is A, tedious and awful, and B, you're stuck in TROF for the rest of your life. And even then, I knew I didn't want to be stuck in TROF for the rest of my life. And C, I wanted to output 2 different outputs. I wanted to output TROF for the exam and TROF for the key, because, the key, I wanted to use the same file to generate both the exam and the key and just mark the answer as part of the thing. So I wrote a whole bunch of M4 macros that did all this. And it wasn't that hard. I say a whole bunch. It was probably 100 lines of M4. Maybe less. And I started to add things like how to get TROF to invoke EQN to do some equation stuff and that kind of thing. And a little macro language for writing exam. Later, I got tired of TROF and actually rewrote the things so they could wrote a new set of M4 macros that had the same API that would emit LaTeX instead, so I could choose to use either the generate TROP or LaTeX. Eventually, obviously, I wanted to be able to do HTML, so I wrote another set that would generate HTML because the web. And anymore, honestly, I just write my exams directly in LaTeX because that turns out to work fine in the modern world for everything. But that was literally 20 years of using these M4 macros to generate a whole bunch of exams. It was a simple little system. I never needed more than it provided. And if I did need some little addition, it was literally a minute. Not one of those hypothetical talk minutes, but a real honest-to-gosh minute to just add another macro to the API, and then you're off and going again. And the macro definitions aren't that hard to write. None of this was even really, very much of this was even recursive. I don't think any of it was. It was just so easy to write, so easy to maintain. It's still available somewhere. I think it's on BartForge if you want to look at it. So, what are the scary parts of M4? You know, the biggest thing is that it surprises during expansion. Either something's expanded when you didn't expect it, or something isn't expanded when you did. And it's, you know, so you got to kind of keep your eyes open for that. You know, you really, the convention of having your macro names be all caps, you know, is a good idea for the same reason it's a good idea in CPP. It's so that you really got some idea of what's going to expand. You really want to use as many quotes as you can get away with, because you'd rather have things not expand when they're supposed to, you know, when you intended them, because then it emits something that sort of you can see, oh, gee, I have too many quotes there, rather than the other thing, which, if you've got recursion, tends to result in infinite recursion. And like we were showing earlier, watch which $1 you're getting, because if you've got nested definitions, it could be one of several. By the way, LaTeX, everybody who does nested definitions has this problem. It's not like it's unique. But the fact that the arguments are positional instead of named makes it worse, because you can't fix it by using the names. And, you know, obviously, you saw how easy it is to just interact with M4 at the command line. You know, unit test your stuff, right? Make sure that each little macro you write sort of seems to be doing something sensible before you start building them on top of each other, because the bad thing. And in general, I'd say that M4, more than most things, really, really benefits from sort of, not capital T, but probably small t, test-driven development. You really want to find out what your macro is supposed to do and be pretty sure of that. And then you want to build some tests, and then you want to build your macro. It really works better than going the other way around. Because, and this is too bad, oh, sorry. Yeah, this slide. The M4 debugging problem. The problem isn't really lack of debugging tools. There's all kinds of debugging flags and modes and this and that in GNU M4 that you can try to turn on. The problem is the lack of any kind of debugging methodology. It's just really hard to know what debugging tools you'd want, and so they provide some, but they don't turn out to be terribly useful. The problem is that, you know, first of all, you know, there's no, like, well, which variables have which values? There are no variables, right? There are these definitions. They all expand to text. The only thing you can really do is look at what the definition is and then see if it's something you're happy with, but that's what you did when you wrote it, so what the? You know, you can sort of, you sort of can't examine how something's expanding. You can, I mean, GNU M4 will help you do that, but it isn't usually very useful because you just end up with this string of 50, you know, expanded macros, and you know, it's like, should that have been 50 or 49 or 51? I don't know, you know, I can't read it, can't count them by hand. I can't even do printf debugging, right, which is sort of the traditional fallback. There's almost no languages, Haskell being the notable exception, where I can't do printf debugging because, you know, almost always there's some way to tell the I/O system. Even in Haskell, I can stick a, you know, unsafe perform I/O in there somewhere and do some printf debugging, although it's confusing what it's going to do. Here I don't even have that. There's just sort of, everything's going to stay. So what am I supposed to do? So the point is that maybe the only legitimate reason to be a little scared of M4 is that you have a bigger burden than you do in most languages to get code right in the first place.
Can't you use a diversion for debugging?
Absolutely. You can divert stuff if that's useful, and then undivert at the end to see what went into the diversion. There's all kinds of little, you know, case-by-case kludges like that that you can do. Like I say, there's some tools that are supposed to help, but the point is that much more than other languages that I'm used to, it's both easy to make buggy programs and you pay a huge penalty for buggy programs, and so it just takes more care for language stuff. Not huge amounts more, but enough more to make it something to pay attention to. Look, again, when we generated XCB, when we did XCB the first time, what happened was Jamie Sharp, who many of you may know, was brand new at Portland State. And I was talking with him about this project. Yeah, what we really need to do is generate the backend using M4. Here, come here and I'll show you how to use M4. And I sat down with him for probably an hour and a half and gave him a little M4 tutorial, much like this one, only a little more. And he said, oh yeah, you might want to start working on that. And I went and told Keith Packard what I did. He's like, you're awful, you're evil. How can you do that to this poor innocent kid, right? And I came back on Monday. I'm like, Jamie, I'm really sorry. I should have walked you through more of this. And he said, I'm almost done. He had like 300 lines of M4 macros. They did pretty much exactly what we wanted to have them to do. It's certainly doable. There's absolutely no reason you can't get this right. You just have to go slowly and pay attention and take care. And compared to getting it right in Python or Perl or Haskell or whatever your other thing was, typically it's less total work if you do it carefully, by a lot, for simple little things like this. But there comes a point typically, and this is the biggest problem with sendmail config and with auto tools, when it's maybe time to abandon your M4 solution and go to some real honest-to-gosh crafted solution. Something where the compiler has a chance of emitting reasonable error messages and where your grammar can be a little more complicated than nested expressions and blah, 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 right? And at some point, if you get beyond the prototyping stage, when you've written 5,000 lines of M4, you've probably done it wrong. You probably long ago should have done it when it built a real system.
So, it wasn't on your list, but I think the biggest scary I've seen with M4 is that clever is forever in M4. If you've got multiple people working on something and somebody comes up with a clever, useful feature, it's there forever. And refactoring M4 is the biggest friggin' pain.
It's very difficult unless it was written well, and if it has clever code in it, then by definition it wasn't written well. Yes, absolutely.
Clever is permanent. Somebody thinks clever in M4 and you're, damn, we're stuck with that for years.
Yes, absolutely can't argue with your analysis. And probably the biggest pro GNU M4 extensions argument I can make is that they offer sort of a standard API for a bunch of things that otherwise people would keep inventing for themselves badly. And so, if you either invent it less badly or just use the GNU M4 extension, one or the other. I agree completely. But the point is that, that one reason to walk away is because your system really is too complicated for this little prototyping tool thing. Another reason to walk away is because you want somebody to work with you who hasn't heard this talk. Oh, I couldn't touch it, it's M4, you're on your own on this one. Literally, an entire community of developers like, no, we couldn't possibly work on this, it's in M4. Oh, okay, well, so you should anticipate that up front. If you or your smart friends are the primary audience that you use M4. And yeah, yes, it's Turing complete, that doesn't make it a good software development language. There's no modularity, there's no type checking, there's a whole bunch of things that you'd really, really like to have in order to make it something good to develop large software projects.
So if you define a macro A, let's say, and then later define a B using A, that's something you can do, right?
Sure, absolutely.
And then 10 lines later, you redefine A.
Yep.
What happens to B? Is that the previous A, or does it pick up the new A?
You've got full control over the expansion. What happened? Did you define B in terms of the expansion of A, or did you define B in terms of the symbol A? If it was the expansion, then that ain't going to change because it's already got expanded before you redefined A. If it was the symbol, then when that symbol is finally expanded, it'll be expanded using the new definition, right? So it depends on how much you quoted it. You get to decide. You gotta be careful. So my argument, I guess, is that M4 isn't wrong, it's just misunderstood. It's absolutely an effective DSL tool. I've used it that way 6 times now. I think I qualified to say that. It's absolutely better for prototyping than for major production use. Having tried it both ways, I'll vouch for that. You have to be more careful with it than with some other programming formalisms that you may have used. It's not. It is a sharp tool. And the other thing is that the reason it's misunderstood is because nobody ever actually gets beyond their fear of it and actually sits down and types at it for 15 minutes. I mean, literally in 2 hours you can be comfortable with this. It's not a hard system to learn. There's nothing difficult or magic or clever about it. You won't find a lot of M4 tutorials on the net, A, I guess because people are scared of it, but B, because you don't need a tutorial. It's frickin' M4. How wrong could you possibly go? So, I guess that's my conclusion.
Just watch this video again if you don't know what
Yeah,
you're doing.
exactly. So, I guess that's my conclusion. Oh, that's right, I haven't been paying attention to the camera at all. I really apologize. That's my conclusion, is that, next time somebody tries to scare you about M4, just laugh. And, do go take the hour and a half, 2 hours sometimes to sit down and play with it for a few minutes. Just play with it a little bit and see what it does. I think it'll be pleasant to sometimes.
What's M4 implemented in?
See? No, not an M4. That would be bad.
But if your M4-based solution gets too big and too complex, you should be able to use M4 to translate it to another language.
Yeah, absolutely. Absolutely. I'm trying to remember if that's what we did with XCP. I wouldn't swear it wasn't. I don't remember anymore. It was a long time ago. But yeah, that's one of the nice things, is that sort of putting a new back end in is just redefining all the macros in some API to be the new back end macros, right? And you're done. How easy is that? Absolutely.
Is this a little tool that's always been in my Debian distro, or do I have to go find it?
No, it's probably installed by default. If not, it's apt-get install M4. I think it's still installed by default, though. I think it's part of the utils or something. But I wouldn't swear.
Stuff depends on it. It's
Yeah.
used internally. So.
Yeah, because SendMail and AutoTools at least depend on it. If you've got either of those installed, then or Postfix or modern SendMail, then if you've got any of those installed, you have it already. But I think it's part of the utils or something like that. But if not, like I say, apt-get install M4.
Does Postfix use it? I don't know Postfix.
I think Postfix still uses it. I could be wrong. I don't know. I don't use Postfix.
Does the web literate programming stuff of LaTeX source use it, or
Does the what?
like the stuff LaTeX is written in the literate source C?
No. LaTeX. Web is its own pile of C code. That's another macro system.
Well, LaTeX written in tech, right?
Yeah, LaTeX written in tech, but he's asking about web, which is this thing that allows you to
Yeah.
mix
Text is written
a
in web.
document with your
Pascal.
yeah,
basically.
with your stuff. So and that one is
Yeah.
that's a separate macro preprocessor. Knuth was really into macro preprocessors. That should be a good sign, right? I mean, he's a pretty smart guy. So
Sign of what?
what sign that
The smart guy thing isn't
sign
necessarily
that something like
endorsement.
M4. Well, no, I mean.
It's not that only smart guys can use it.
A couple of people, well, a couple of people use tech. I mean, it isn't, it's hardly a one
Sure.
person project. Yeah. So the last thing I wanted to say, and I'm sorry this is a little more serious than I usually am, but one of the last, when I was busy trying to get this thing into Open Source Bridge and talking about this talk, basically this talk is the talk I wanted to give there. One of the last public messages I know of that eGall posted was a message talking about M4 and making fun of it in fine Cthulhuian terms. And it was something that really I thought was hilarious at the time and had big fun with it. And looking back at it a few months ago, I thought it was pretty cool. So I really wanted to, and I hope this is okay, dedicate this talk a little bit to eGall, who, really understood M4 from having used it, and I wish you guys were here to echo it. So yeah,